some details on the journey that we're going through still, like regarding deploying a little bit of intelligence to the edge in the oil and gas. So just for setting the context, so I work for Schulumberger, or I've been working for Schulumberger for the last 12 years. Schulumberger is an oil field company, which basically provides technology and services across the whole spectrum of the life cycle in oil and gas. So more specifically, I work on the SLIC, which is a technology center located in Sugar Land, Texas, which is in the Houston area. Which stands for Schlumberger Industrial Internet Center. So we have our focus is in three different areas here. We focus on industrial IoT for basically, it's like a central hub for Schlumberger as a whole for developing the infrastructure for the IoT solutions that we have. We have also some focus on automation, which is basically enabling the field equipment or digitally enabling them. And also another focus on digital avatars or digital twins, which is a very hot topic that has been covered here in this forum very nicely. So just to make some brief comparisons between the consumer IoT and the oil field IIoT, right, the industrial IoT. So when you look into the consumer IoT, basically the first thing that it comes to mind is your smartwatches or the many things that you have at home, like your smart fridges, smart lamps, smart TVs, smart whatever, right? And one thing about these devices is that they are basically born IoT enabled. They are born IoT connected, right? So, and we always assume using these devices that we always have good connectivity, right? And typically we're angry if we don't have connectivity for 30 seconds. So now when we turn to the oil field scenario, so this is not necessarily true because one of the things is that our operations typically are running in remote locations, right, where connectivity is an issue, right? And the other thing is that our devices are not necessarily new, right? We have a whole fleet of equipment which is old, right? It is extremely valuable, but it's an old equipment. It's not IoT enabled, right? And it's not smart enough, but still we have to find a way to make these devices a little bit smarter or the processes that use those devices or those equipments a little bit smarter so that we can improve the efficiency and sustainability of our operations in general, right? And the other thing that is pushing, or it's a stronger push for IoT in the oil field is with COVID, just like any other business, right? So to enable the remote operations, right? And the other aspect that is very different is we're dealing with critical infrastructure with lots of safety concerns in running the job itself, right? So one factor which has to be taken into account is very, very seriously is the robustness of the systems that we deploy there. So we're talking about the edge. So in this context, the edge is the well site, and the well site is not necessarily a nice environment. It's typically a harsh environment. So you have high temperature, you have high humidity, you have vibration, you have lots of dust, shock, etc. Right? So all these conditions combined create a very challenging environment for your hardware and software to operate properly. So one of the things that typically you have to do is ruggedize your equipment, right, to make it to work properly, right? And typically you have in this area here, you have two types of equipment. So you have what we call the surface equipment, which by definition it's on the surface. And you have the downhole equipment, which is the equipment that you put down the well, right? And then now you can imagine, right, you have this metallic cylinder, and then you put your electronic with your firmware there, and then you have temperatures above 100 C with humidity. Humidity becomes steam, and then you get the point, right? So the other thing that mentioning regarding the connectivity, right? We are typically in remote locations, like where the only resort sometimes is for communication. If any is using satellite, which is a bit flaky, so high latency, outages happen very often, right? So Another aspect here is regarding data. Data is king, and there has been like a paradigm shift where we process this data. So in the beginning, used to have everything being done at the edge of the well field with your local human expert with access with the data, and people distributed in different areas with all the silos. People don't talk to each other, right? And then it starts to have this movement. Okay, let's make our devices dumb and push everything to the cloud, right? And to solve this problem, right? But we have, as we're saying, so we have this problem with connectivity, right? So this is one thing. Problem with bandwidth because satellite is expensive. And who said that your client is willing to push all its precious data to the cloud, right? So then what we've seen more in the last few years is more like a sort of not going back entirely to edge, but more like a hybrid model, right? So you keep everything that you have to keep close to where the action is happening, and send only the relevant thing to the cloud as needed. So taking all of that into account, so communication, I think that's already pretty clear, right? So again, typically when we are working with IoT in the oil fields, typically we say that sometimes we don't have the I in IoT, right? So you have to design your system to make sure that it works autonomously in case you're in an offline state. And also you have to think always in the bandwidth optimization because of the costs of satellite communication. Security, I think it's bottom line is security is important regardless of the IoT type, right? The difference here is that because of we're dealing with things that have a very high agency risk potential. So an incident here or security incident can have a catastrophic impact. So resilience. So we're running like mission critical operations that cannot fail. So you have to think that in ways to make sure that your operation will keep running as expected. We have all of these problems that we have to deal with, and at the same point, we have to make sure that we had the factor of extensibility. The meaning here is we have to simplify the life of the domain expert that are solving a domain problem, right? So that they can focus on their domain problem, and the rest is sort of abstracted to them, right? So that's the only way, and make sure that these different small solutions can operate with each other. Otherwise, it's very difficult to grow as a whole. Remote operations, more and more. I think this is something that has been repeated over and over here in this several days of this forum, right? So the things with the connected workers, right? And also here, we're dealing with a fleet of devices that we have to be able to manage at scale, right? And make sure that we provide the tooling and the smart alerting, or making sure that our operations team that is managing those devices, they are brought to attention to the specific devices that need attention. Last but not least, data residency. So in this case, public cloud, in-country, on-prem, you need all of this, right? Public cloud, not all customers are really open to use that, right? Some of them are, right? There is an advantage because you can leverage the native managed services that the cloud providers give you. Then you have the in-country, where sometimes you have government regulations. You have to ensure that everything is within the boundaries of a specific country or region. And then you have the case of on-prem, right, or the hard on-prem, as you call it, which in the case where the client basically everything keeps within their network perimeter. Yeah. So basically, this is sort of the things that we have to enable deploying things and operate the things that we deploy. At the middle of this, we have what we call our edge gateway, right? This edge gateway. And the left-hand side here, you see your devices that you're operating, right? And then typically you have some sort of controller in front of those devices. And then the gateway is communicating to those devices via like several different protocols like Modbus, LPC UA, and others, right? And from the gateway to the cloud, so the typical communication media, you have satellite and you have cellular as well that is supported. And one thing is that when we onboard devices to our cloud system, so we have to ensure that we have a strong identity. So on these devices, so leveraging things like a TPM, like a trust platform module, it's very important. So to ensure that we have a strong identity, we can ensure that the device that is connecting to your system is really the device, your device, right? And then on the right-hand side here, you have these three different areas, right? The concept of the marketplace. What happened here? What did I do? I don't know. All right. Okay. Let me go back here. Yeah. So the concept of the marketplace here, right? So where you have this suite of different solutions that you can pick and choose to solve a specific problem and deploy to your system, to your gateways or to your fleet of gateways. For data control, like ingest the data from your devices at scale, and have the ability to control those devices, has visualization interfaces, so on and so forth, as well as device management support. Right, this is really critical. Having a single pane of glass to provide to our operations team, so that they can manage their devices remotely and in an efficient manner. So when we look inside typical edge gateway, right? So this is what we think. So we have typically you have your hardware layer, you have your industrial computer, and then you have your operating system, and then the idea is that you have your sort of plugins that you have on top of your of your operating system, right? But in order to have that in an efficient manner, so it's surprise, it's not we have containers, right? So it's today basically we no longer have a monolith, right? So we're trying to break things apart so that it becomes more manageable. But yeah, it's not only like, okay, I put in a container, I deploy, and then, okay, it's done, right? It's a little bit more complicated like that, because you want to make sure that whatever you deploy, you can operate with the other thing that you have deployed in your system in a more efficient manner, right? So you have to provide some sort of layer with some core services, right? With message broking, like security monitoring, health monitoring metrics, right? Access to peripherals, means to access your gateway locally in an offline mode securely, like using like YubiKeys, ephemeral certificates, so on and so forth, doing like over-the-air updates of your operating system. And then you have to provide the basics, like as part of the platform, the basics of your southbound protocols, like your components that come out of the box that already talk the protocols of your devices that you're connecting to from the gateway, and bring that are acquiring this data and bringing this data into the system in a common data format, right? So the idea to normalize so that it's a bit easier to exchange information between these things, right? Data management, so things to get the data either from your southbound devices or from modules that are computing some sort of derived data, right? And bring into the same in a single place where you can manage this data. And cloud connectors, right? Something that can manage the connections, the secure connection between your gateway and your cloud provider or your remote server, and in which this cloud connector behaves as a cloud gateway, like acting as a proxy between what's happening on the gateway and also receiving commands from from your remote server, from your cloud, right? And then you have your edge computing modules, which is the things that we try to isolate, things that the solutions that or the specific solutions that are trying to resolve some specific problem, right? That we try to isolate from all of this, right? All of this is good. All of this works. The thing is that we have something called legacy applications. Legacy applications, and we have plenty of them. So, and you can just say, okay, just containerize, and then you're good to go. But it's not. It's easier said than done, right? So sometimes the application is huge, it's complex. Sometimes the developers that worked on that application are no longer in the company, right? So this application is in a sort of sustaining mode. Sometimes there's no business priority for that, right? There's always like lots of things that are happening that need to be prioritized. So but the point is that all of these things, they're still working and they generate revenue. So the thing is that legacy and the more modern things, they have to coexist. There is no option of that, alternative for that. So another type of requirement that we're seeing is to supporting like clustering and failover, either within the same gateway or between different gateways, right? So first thing that comes to mind, like isn't that cloud, right? So you think in Kubernetes, you think all the things that you have in your Kubernetes clusters in the cloud, and that's right. I think it's more and more like the infrastructure. You're needing like an infrastructure at the edge, which has some similarities in terms of features to what we have in the cloud, right? And also, again, device management. Now, device management for all this additional infrastructure, right, and securely and at scale, right? So, if you look, you try to update the last diagram. This is more the thing that you're looking at, so that you have to have. So, you have everything that we had in the previous slide, plus have your clusters, plus the support to have your VMs running with either Windows, Linux, or whatever you need, right? Which means that pretty much you need this hypervisor, this virtualization engine to support that. Now, just going through some, so all of this infrastructure that we have to build to support or to simplify, as I was saying earlier, right? To simplify of the domain expert to solve some specific problem and focus only on that particular problem. So there's this use case here, like with video analytics, right? So again, we're talking about this old equipment, this aging assets that we have to maximize their use, right? So there's this specific case here where there's an offshore rig, right, in a remote location. So you have these gauges, and these gauges, they are not connected through a DCS. So, and from time to time, what happens is that operator needs to send the technicians to this remote location to this to basically do the manual data acquisition, right? So the guy is going to read the gauges, annotate, and then take it back, right? So we have a few problems here, right? So first, you're increasing the agency exposure of the particular person, right? And it is an extremely inefficient surveillance mode, right? And you're lacking opportunities to do troubleshooting and to optimize your system. And then solution here is, it's not as easy as we might think, like, okay, let's just replace and put modern gauges and it's done, right? So it's you have a limited CapEx budget, and you have to maximize the use of those devices. You have to recertify all the things. So what can we do? So we can deploy a gateway to that location, and we can connect a camera to it, right? And then you work on that model. You put that camera facing the gauges, and then you work on a model that is going to read all those gauges and is going to digitize the readings, and is going to digitize and then stream this data to the cloud, right? You train this, and then you containerize your model, and then you deploy as an edge computing module, right? So immediately you're already solving certain problems, right? So you have a more real-time monitoring of your system. You don't have to make your personnel to travel to this remote location, right? So, and you can enable things like having like a dashboard to monitor all of this. You have APIs that you can make available for other cloud applications to to leverage this data that is now being ingested. There's lots of benefits that I already mentioned. I'm not going through these numbers, but you can see that basically, so you can see that for this particular study, you have a huge reduction on the manual effort and the agency exposure, right? And at the same time, there was a benefit and increase on the optimization of the system. This is a simple example, but you see that with a little bit of creativity, you can still work around your limitations and still provide some value for someone, right? In our business. Other use cases. So there are multiple, like for example, in a facility. Monitoring, like using video analytics for agency surveillance, like. So you have to comply with using like PPE, right? So you can use that basically to track if people is using like hard hat, gloves, boots, and so on, right? And then monitor that and see if people is being compliant. And then this is good information for management to take some action, right? And also other things is like red zone detection, right? So sometimes you're not supposed to operate an equipment. If a person is located in a specific area, you can have mapped that specific location and then alert if someone is going there and avoid that someone gets hurt, right? More recently, like today we don't have those restrictions anymore, but things like enforcing COVID-19 guidelines, like use of masks, social distancing, this is something as well that you can keep track of. Another case is flare stack. Flare stack is this is a typical image that you associate with the oil and gas business. It's not only the oil and gas business, but there are other industries as well. But basically, this is you have this tall pole-like structure, right? Where you have like flames coming out of it. So this is pretty much like a gas combustion device, and the purpose of this is there are multiple purposes. Like you have to one of them is to manage the gas waste, right? Gas that can be processed, or it can be used for stabilize well pressure and flow, or for in case of an emergency to release pressure, right? And one problem here is that most of the gas here is methane. Methane, CO2 is bad for the environment. Methane is worse when it comes to contributions to global warming, right? So the idea is that you have to optimize so that you burn this methane before it gets to the atmosphere, right? So here's basically the problem or the challenge is methane is it's invisible to the naked eye, right? And we have too many flare stacks to monitor, so you have the typical problem of efficiency, right? So if you have this solution that you can you're monitoring the video streams, and this can work in different conditions, day, night, smoky, clear sky or cloudy. And you're going to have an alert much earlier, right? And this is going to ensure that you can optimize this device for maximizing the efficiency, right? Another use case here is methane leak detection in tanks and pipelines. So this one is it's as I mentioned. So methane is invisible to the naked eye. So, and one thing that might cause these leaks is like this old equipment, so you can have like a corrosion, mechanical failure, etc., right? And it's good that you can monitor your critical infrastructure from a distance, right? So leveraging like things like optical gas imaging technologies, you can install things on your in your facility, monitoring your critical assets, and provide immediate value, right? So continuous monitoring from regarding these particular problems. Another uses for regular inspections is having like a portable sniffer that communicates with your gateway, and then that informs or ingests data immediately into the system. Another different use case here. So one of the things, or one of the common problems that we see in the SCADA systems is that typically the optimization of those systems doesn't take into account the historical data. And in some cases, in some locations, you have too many wells for a single person to monitor or take care of. And then what happens is that there's a specific case where liquid loading events were happening. So when this happens, someone has to travel to the location again. So exposure, HSE exposure. It's NPT, non-productive time. So when someone is intervening to resolve this problem, the production needs to stop, right? So you can put a gateway there, develop an application, an algorithm based on the physics to monitor that more frequently, taking care the data that you're aggregating in the cloud to optimize your model, deploying back this into your gateways, and then you can actually make this algorithm take care of controlling the choke set points, so without any intervention. So for this particular study that was it's being reported is it's a huge. I think the biggest impact is a reduction in the manual intervention. So so someone that didn't have to travel to the location, right? So that's a huge benefit, as well as an increase in production. So these are just some examples that despite having these equipments that are not necessarily new, right? So there are always, but we still have ways to optimize them or make them a little bit smarter, right? And improving our operations, right? So also just some concluding things here. So IoT applied to oil field present its unique challenges, just like in any other industry, right? So our Edge Gateway has evolved significantly, and the way we deploy applications changed, and it's still changing, right? So one thing is that we came to realize that there is a modern applications, greenfield applications, they have to coexist, and they have to coexist for a long time with the legacy applications. So virtualization, it's a capability that we consider as key for our future here. So, and remote operations, right? So all the device management, this is not a small thing. So ability to do most of your work remotely at scale and safely and securely, right? Giving the right permissions only for those who have a reason to perform certain operations, right? This is a necessary thing, and it's not it's a huge amount of work to get there. And there are many other cases that countless opportunities to improve the operations that of our oil field with this approach. So I think this is just the beginning of this journey. So and I think that's pretty much what I had to talk about today. So thank you.